How is it possible? Is it possible to carry the information through wires? Wire, when I say it, it's a copper wire. We have been using it. Electricity, எப்படி அனுப்புறோம்? காப்பர் வழியாக தான் அனுப்புறோம். அது என்ன ஆகுது? Electron, flow of electron. Flow of electron is responsible for the flow of current. They do in opposite direction. Now, they have a difficulty. They have a limit otherwise to carry the data. That is where the light was helping us. All of us know light is the fastest traveling now particle, we can say. So far, nothing faster than the light, you can imagine it, right? They've been trying to disprove Einstein theory, but still they were not successful. As on today, the fastest traveling particle is light. There is no question on that. Now light, when I do it, how do I travel? I also see the light traveling in space, but you have to have a waveguide. You have to carry the data through the light, using light, the fiber we always use it. The glass fibers, plastic fibers, they are all scientific contributions. They have already done research on the fiber technology. Now when you send the light from one end, you can see the light coming at the end. That is how the transmission of the data, these two have helped. Now we have a telephone connectivity undersea between different countries. For example, Singapore and Chennai. Otherwise, olden days, they had to talk, tuck, 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 tuck. Technology was different. Now we just like that call, because of the fiber optic communication. Now entire India is networked by fibers. And we have a transmission of data and from any part of the country because of the technology development, because of the science has been the mother for this. Right. So this is the importance of basic science. I thought, let me begin with the basic requirement of science, electron and photon. This covers your area of physics and chemistry together. And also you have studied about electron, but you may not know what are the technologies that are coming out of the electron discoveries, photon discoveries. I cannot discuss all the technology also. I will discuss few of them and try to give you, enlighten you some of the information. Right. So when you study about electron, it is called as electronics. When you study about photon, it is called as a photonics. How many of you know the word photonics? Right. So if you are very much interested in physics, you may know that it is mix of the electron going into this photon. So it is photonics. Now I also should mention today's science is tomorrow's technology. Right? If you have science today, maybe 25 years from now you can see the technology. That is how the electron, when was the electron discovered? How many years old electron? So all of you have studied in your science subject, you know the person who has discovered electron? Thomson. So which year was that? So somewhere in the beginning of last century, right? So in fact, we have celebrated 100 years of electron, 100 years of photon. Another interesting aspect, next year, 2015 is declared as the year of the light. So 2015 is the year of light, and we have already crossed 100 years of both. An electron is a bigger brother, photon is an younger brother. Because electron was discovered earlier, they were there, right? They were there when the universe has begun this life. But we have not realized what is this. That is what is the understanding of the nature, that is what is basically called as the science. Electron, when you look at it, J.J. Thomson, he got the Nobel Prize in 1906 for discovering the elementary particles. Another interesting aspect, his son also got the Nobel Prize, right, for in the year of 1937 for the wave nature of the electron. This is what you can realize it. Both the father and son got the Nobel Prize, and that is an interesting aspect. So that has been the real discovery, we can say. If you assume it now, electron is not discovered. What is our world now? You may not see the light. You are in back to another 2 centuries, 3 centuries back, dark world, because electron has shown you a way. So that is a basic science, right? You would have spent a lot of time. All of you know about Thomas Alva Edison. How many of you know the story of Thomas Alva Edison? What is the interesting story about it? Right. So what is the message you have with that? Keep trying, keep trying. Vidamuyarchi. Tamil சொல்ற vidamuyarchi. Persistence is very, very important. Right? தோல்வியை கண்டு துவளாதே தமிழ் சொல்றோம். Right. That is what is important. Right? So now we know many things about electron. Let me summarize it. Electron was discovered by Thomson and by a simple experiment cathode ray tube. And also look at the charge on the electron, mass on the electron. Otherwise you can look at the E by M ratio he has given it. And charge of electron again done by Millikan by oil drop experiment. And charge on electron is 1.6 to the power minus 19 coulombs. Mass of electron is 9.1 to the power minus 28 grams. Electron is approximately 2000 times lighter than hydrogen. These are the basics we know already. If they are not given you the basic, where is the technology? So this is where you have to realize it. Okay, இதெல்லாம் தெரியும்பா பழங்கதை அப்படின்னு சொல்லுவாங்க. But பழசு இல்லாம புதுசு இல்லை. பழசுல இருந்து the old is always gold, we say it, right? So they all come from that. Now if you look at the properties of the electron, most important properties, they have the angular momentum. Why there is an angular momentum? The electron, all of you know, there are 2 motions. One is the spin motion, the other is the orbital motion. Spin and orbit. You always see that the electron is moving around the nucleus in a spin way and orbital way. Example, good example, you know that. You cannot see, I cannot see electron, but I can see the globe. Globe is revolving around the sun. That's an orbital motion. Rotating on its own axis, that is your spin motion, right? So you can really see that electron has come from the earth. So it is carrying the same property. Right? தாயை போல பிள்ளை சேலை போல நூலை போல சேலை. That's what we say. Exactly it has the same property. Right? So now you can look at the spin and angular momentum. What do? They create a magnetic moment. So all your magnetism you study about it. You would have studied about permanent magnets, temporary magnets, electromagnets, antiferromagnets, all these magnets that you are using it, you already studied it, they are all available as the materials for application, materials for technology also, right? So these are the few things you should realize. The electron simple properties, they used it into technology materials. And another interesting as they have the motions quantized, quantization of the motions, spin is quantized, orbital is quantized, spin quantum number is of plus or minus. You know, when you go up in your higher education, you will see there is a 5th quantum number, which is basically called as a magnetic spin quantum number. Only then you say it is a plus or minus of. Otherwise, you would have been taught only 4 quantum numbers right now. So you know only the principal quantum number, orbital quantum number, magnetic orbital quantum number. Otherwise, you call it like a azimuthal quantum number. Next is the spin quantum number. 5th one is the magnetic spin quantum number. That is where you put the plus and minus off, right? So that is where you realize there is a magnetic property. So magnetic moment. Now let me ask a question. Which magnetic moment is larger in magnitude, do you think? Which one is larger? There are 2 motions. One is the spin motion. Next one is orbital motion. Which do you think will give you a larger magnetic moment? So how many of you say orbital magnetic moment? Nobody says. Only one you see. How many of you say spin magnetic moment is larger in magnetic? So what about others? You don't know the answer? Simple logic. பூமி தன்னைத்தானே ஒரு வருஷத்துக்கு எத்தனை சுற்றுது? நிறைய சுத்தி வந்தா மேக்னெட்டிக் மொமெண்ட் ஜாஸ்தியா இருக்குமா கம்மியா இருக்குமா? நல்ல எக்ஸாம்பிள், விநாயக பெருமான் முருகனை நினைச்சு காட்டுங்க. முருகன் சொன்ன உடனே மயில் மேல ஏறிட்டாரு, உலகத்தை நான் நொடியில சுற்றி வரேன்னு. பிள்ளையார் ரொம்ப புத்திசாலி, அழகா அம்மா அப்பா சுத்தினாரு, பழத்தை வாங்கிட்டாரு. அதனாலதான் படம் நீயப்பான்னு பாட்டே வந்தது, அவை பாட்டி பாடினாங்க. ரைட்? So spin motion is a larger magnetic moment compared to the orbital motion. You can say 99% of the magnetic moment that you see in the electron is because of the spin motion. Orbital is very less in contribution. You also know that the electron is a dual in nature. It is particle as well as wave in nature. This is what is important. And again, D. Broglie has given you the wavelength. Right, lambda is equal to h by momentum, h by momentum, right? And you can also look at the energy of that is E is equal to mc square. So these are the properties. We have taken a stock of the properties. Now, what are the phenomena that you see out of the electron? We know already electricity. So we now carry electricity. So now when we see Tamil Nadu, there is a lot of shortage of electricity, power cut, right? We have to produce electricity. Not only producing, we have to transmit electricity. That is very important. How many of you know that how much is the percentage of loss of electricity transmission? When you are transmitting from one end to the other end, how much is the loss that happens? Do you think 100% efficient? How much is the loss? I'm asking the loss. So these are the things you should know it, because you should have a research attitude. Let me find out a new material which can be more effective in transmitting the electron. This is where the science has been growing. And that is how there are materials called as a superconducting materials. What is a superconducting material?
They are extremely conduct electricity.
Zero resistance. That is very important. So resistance is a problem. It resists. We also try to tell you that, okay, study science. There is always a resistance in your mind. Oh yeah, it doesn't give you enough money. No. There is a resistance, isn't it? So that resistance should go. Now I should make all of you like a superconducting material, superconducting science materials. So that at least I expect 20% of this audience should take up science. I cannot expect 100% to be effective, right? So you have so many compulsions, but at least 20% take up science and do it. Science is the real brain behind the technology. That is what you should feel it. And also you have almost 90% is a loss in transmission. Only 10% you are carrying from one end to the other. So big loss is there. How is it lost? Because of heat, resistance is there. So you have to find a material which can carry more effectively. That is how they have been trying it. If you cool all these materials to liquid nitrogen, temperatures are to a 0 degree Kelvin. You can see that the materials do not have the resistance. But how do I cool the wires that are carrying electricity to liquid nitrogen or a lower temperature? It's very, very difficult. So that is where you should have new materials. That is how they have started working on a copper oxide materials. They are trying to give you the new superconducting materials. Still as on today, it was not 100% successful. There was a research, but it was not successful. Now they realize it is very, very difficult to make a material which can have zero resistance. Not necessarily zero resistance, there will be an improvement where they can show lower resistance. At room temperature, that is very, very important. I should have a material which can have a lower resistance than the copper wire, right? And that should also be made as a wire form, not in a crystal form or a solid form. It has to be drawn into the wire form which can transmit the electricity from one end to the other. This is what is the requirement as on today. If somebody, some of you, invents new material, I assure you will get a Nobel Prize. This is very, very important because it is a demand of the system now. If you have new materials, yes, it is going to be the success. Another interesting aspect is the bonding. You know, all of you know that when you study chemistry, you make bonds, right? Bond between two atoms. So what is the role of electron here? It is like a glue between atoms. It is like a paste between atoms. Electron binds two atoms together, a number of atoms make a bond, and that is very, very interesting. See the chemical bonding. All of you know many bonding, right? So what are the bondings you are studying now? Good, memory is good, yeah? So sigma bond we say it, the covalent bond, right? Pi bond we say it is also a covalent bond. What is the basic difference between the sigma bond and pi bond?
Head-on overlapping and it is lateral.
Direct overlap and lateral overlap. Do you know there is one more pi bond bilateral overlap? Sigma pi. What is the next bond? Delta bond. Good. There is an answer. Delta bond. So what's the delta bond? It's a lateral overlap between the d orbitals. We have the d orbitals. எத்தனை பேருக்கு d orbital தெரியும்? அதுக்கு அடுத்தபடியா ஒரு orbital இருக்கு. அது என்ன orbital? Very good. So you have f orbital, right? So the sigma, pi, delta. If there is an overlap between the f orbital, what will you call it? Right. What is the bond you call it? Lanthanide is fine. It's the family of the elements. But if there is a bond between the f orbitals laterally, what will you call it? Sigma, pi, delta, next letter. Sigma star. You like superstar? Okay. You like superstar, I see that. That's the reason I put a star on that. Gamma. You can say gamma, right? It's a nomenclature, basically naming. Naming given, yes, let's settle down, right? So the nomenclature is very important, and that is where you get a different bonding system. For all chemical bonding, important particle is electron. Without the electron, no bonding, right? So the bonding materials that are available in nature, many, right? இந்த யுகத்துக்கு முன்னாடி இருந்தே இருக்குது. இந்த யுகத்துக்கு பேர் என்ன? யுகம். இதுக்கு முன்னாடி யுகத்துக்கு பேர் என்ன? உங்க தாத்தா பேர் என்ன? உங்க தாத்தா பேர் என்ன? That's a problem. So we don't want to understand our ancestors. There is no connection. That is the reason why Lord Krishna has shown up again preached Bhagavad Gita, because connectivity lost. So like this, we have to carry the message, the connection, and that is where you see it. Connection between atoms are very important. They have been existing, but we have been realized only from the last century, right? It's interesting. You see that only after the discovery of the electron, we realize so many bonds between atoms, materials. So we talk about ionic bond, we talk about covalent bond, we talk about coordinate bond. You also talk about other weak bonds like a hydrogen bond. Now if I tell the hydrogen bond is very weaker, some of my chemistry guys will kill me, because now it is claimed as a very strong bond. Just I was told that Gautam was here in the morning, he gave a lecture, DNA, how you are viewing DNA. Helical structure that you are seeing in DNA is because of hydrogen bond, right? So hydrogen bond is also one of the strong bond, you can claim it now. Now look at this, all this phenomenon application, how exactly technology was coming up, electronics, right? Without electron, no electronics. Is it possible? No. So electronics has given you semiconductor devices, the semiconductor devices. Semiconductor devices. So now you can see that ICs, memory devices. You can see these are all coming out of the principles of the electron. And how do we make integrated circuits again? Using the photons. They have been making all these integrated circuits. I'll slowly do that a little later. Using photons, called as the technology lithography. Lithography again came up from the printing technology. So they used it from printing technology. Now we talk about welding. We talk about electric welding. We take electrodes, deposit materials, weld two materials together, and you use the gas discharge and then melt the material and discharge. You can also use the electron beam to weld it now. Electron beam welding is possible because of the higher energy that you have it with the electron beam. Cathode ray tubes, electron microscope, radiation therapy, now treatment in medicine, they use it for cancer and radiation therapy. Another interesting aspect, interesting invention that has taken place in the last century, lasers. In which year lasers were invented? Anyone knows lasers invention? 1980. You like? 1980? No.
50 to 60.
50 to 60. Broad range. The right year is 1960. 1960 was the right year. The laser were really invented, and after the invention of laser, the scenario has changed a lot, right? Your computing devices have changed a lot. Your memory device, what I am using is also a laser. What is this laser? Right, what is this laser? Yeah. Laser is an acronym you are trying to say. What is this laser?
Concentrated.
Concentrated solution.
Light.
Light. How do you concentrate light? Yeah.
I mean, like focus light. Focus concentrated.